Hi guys, this is Mark. In this video, we'll talk about aggregate functions available in Backendless. You see the result of aggregation in a lot of online and mobile applications whenever you need to calculate, for instance, number of comments for a post, or average rating of a product, or minimum and maximum prices whenever you search for airfares, for instance. Those are the results of aggregate functions. And being able to calculate those numbers quickly and efficiently and have the database do it for you is what makes databases quite powerful. In Backendless, there are five different functions that we support, and those are count, min, max to calculate minimum value and maximum value for a range of records, calculating averages, the AVG function, and sum. These are the 5 functions that we support. And you can calculate these values for the entire data set that you have in your database, and provide additional conditions for which records need to be included to calculate these values. And I will go over various examples to demonstrate how aggregate functions work in Backendless. So let's just dig in. So this is the schema that we will be using. This is the schema for a database that you already have installed if you're following this course. And in the schema, we do have the order table that has relationship to product and relationship to customer. So for all of these customers, these represented by the customer table, there is a related order table that contains information about the orders placed, and then for every single order there is reference to the product that this order is for. So the first example we're going to review is getting an average price for products in the widget category. So for this, we will be, since it is getting the average price, we will be using the aggregate function AVG, which is average, to calculate average price for a specific category. So in order to use an aggregate function, you would be using it when you describe a parameter. So you'll be adding a parameter that will contain the actual value for the, in this case, average price, and provide a condition that will identify all the products for a specific category. So once this is configured, the result will look like this. So in the properties that you request, you will specify that you need a parameter that is a result of this function. So you will be taking AVG function, and then the argument for this is a column price. So this price is the column, and then the where clause will identify all the records that need to be included to calculate this average. So the where clause, you recognize it is category equals widget, so we're referencing this column category, and we're saying, okay, for all the products, since the query goes to the product table, identify all the records where category is widget, and then for those records, calculate the average price. And then this will result the query that will return the value of the average price for a product. So let's quickly run it in REST console to see how that works. So this is our product table. As you can see, these are the categories, and we want to calculate the average price. Let's head over to REST console. And in here, there is a section called aggregate functions. You can select the function, and that's going to be AVG. And we will be calculating average for the price. And let's identify the where clause. It's going to be category equals widget. Click get, and this is the result that we get. So the result is still an array, because whenever you're fetching data from a table, you will always be getting a collection back. And then this array contains one object that contains this AVG property, and the average price for the product in this category is 57.812. You can assign a alias to this function, and you can just call it, for instance, average price. Click get, and you will see that the property becomes average price. From the structure of this in the actual query, you will notice that this function AVG price is going in as a property. So we are requesting the property to be calculated as the result of that function. So that's how pretty much all aggregate functions will work, is you will be identifying a property that is calculated with the with a specific aggregate function. So this is rather basic example, but it's demonstrative of seeing that function in action. Let's continue. So the next example we will look into is for the same schema, getting average order amount for products in the widget category. So in here, this is going to be different from the previous example because we will have two tables involved in calculating our value of the average order amount. So the average order amount will be calculated for the total column located in the order table. So since we are retrieving average order amount, the query would need to be sent to the order table. However, in our where clause, we need to identify all the products for all the related products for the orders for which we want to calculate this average order amount. And then the where clause will reference the category column from the related table. And since order has a relationship to product, it's through the product column, then the where clause will simply reference product dot category to identify the related products. And the way this is gonna work is we send a request to the order table saying, okay, we want the average order amount, but only for the products that are in that specific category. So the query will look like this. So here we're getting average for the totals. By the way, the request is sent to order to this table. And then the property is AVG total. So we're calculating average for this column, but only for the products that fit this particular where clause. Product, which is this column, dot category, which is this column. So from the product, we do the hop into the product table, and then we reference category. So this is the where clause that identifies all the products in that specific category, and only for those related orders that we identified for the products, we will be calculating the average in our query. Let's take a look in REST console how that would work. So back in REST console, let's switch to the order. Since we are calculating average for the total, here's the total column. And by the way, if we just click get, it will just calculate average for all orders. However, we're not interested in all orders. We're interested in the orders that are for the products. Yeah, it's products.category equals widget. Click get. And I think it is not products, it's actually product. Right. So product.category equals widget, and that's the average price that was paid for all the products that are in this specific category. So that still it is very straightforward, but now we have two tables involved in calculating that average value. And by the way, here you can assign an alias, and that's going to be the property name. Let's move on. And now in this example, it will get a little more complex. We would like to calculate average order amount for products in the widget category and customers coming from an affiliate referral. So in the customer table, there is a column called source, and the source column represents where that customer came from, whether through an affiliate program or Twitter or social media. There are different values in the source column. And one of the values in the source column is affiliate, which designates that customer came through an affiliate program. So in this case, there will be three different tables involved in calculating that average order amount. Total is going to be the actual column that we are aggregating, and that's going to be this getting average order amount. So we will need to be calculating average for the total column, and our where clause needs to identify all the products in the widget category, and this is what we did in the previous example. So it's going to be product.category, and then we will have to reference customer.source and say that this is going to be affiliate, and that will give us the actual where clause. So here it is average. By the way, the request is sent to order, and then we say AVG total, so we're calculating average for the total, and then the where clause references both tables, one for the product and then category to identify that this is widget, and the second part of the where clause says customer.source equals affiliate. And let's take a look at how that would work in REST console. So here we already have average, total, and this is request going to order. And we have product.category widget. And then we're just going to expand that where clause and say, and customer.source equals affiliate. Click get, and that calculates that average. So customer.source, it is, let me just demonstrate what that looks like. So for instance, if we go here and take any given order, navigate to customer, and in here you will see there is a source column. In this case, it is Google because I just clicked the first one. But some of these are going to be affiliate. In fact, you can see that in the source column, they are affiliate, Facebook, organic, and so on. So in the query that we just ran, we aggregated the value for customers from a specific source and products for a specific category. And this way, the query became longer and now includes 3 different tables to calculate one average value. Let's move on to the next example. And here we are going to be calculating average product rating for customers from the Dallas area with order amounts greater than $100. So see the columns that we will be using again are across all 3 tables. Since we are getting the average product rating, the request is going to go into the product table and we will be calculating average on this rating column. And then from the product table, since we have the relationships to other tables, then we will use the in this case pseudo column to hop into the order and then into the customer. So the query here will look like this. So we will be first of all getting average for the product rating and then referencing the order through order product dot total, that's going to be greater than 100, and then referencing customer, again order product and then dot customer and then dot zip. That will give us an idea that they are from the Dallas area. So in order to figure out that they are indeed from the Dallas area, we're going to be using the zip code, and then the zip codes in Dallas, they all start with 7.5. So we can use a pattern matching to say that if the zip code starts with 7.5, they are from the Dallas area. Not very precise, but still fairly accurate in the grand scheme of things. So here, the query for this will look like this. So first of all, the request is sent to product, and we're doing average rating for this column here. And then the where clause goes like this. So order product.customer zip like 7.5. So this will find all the customers that are in the 7.5 whatever zip code. And then the second part is going to be order product total greater than 100. So as you can see, we're using these relationships, and you know how to build those relationships from a number of videos that we have already posted to this course. You're basically using that knowledge to build those more complex where clauses to identify the records which need to be used to create this calculation. So let's build the same thing in REST console. So in REST console, select product, and let's go to REST console, and we will be calculating average for rating for customers that are in the Dallas area. And for this, we will say order dot so we are in the product order dot product dot customer dot zip like 75%. So that's going to basically, if we do it right now, that will be calculating average rating for all the orders that are placed by the customers in the Dallas area. But we also wanted to enhance and specify that we're interested only in the orders where the total is greater than 100. And for this, we say order product total greater than 100. Click get, and now we have this average. So as you can see, this where clause gives you the power to really identify the records which you want to calculate, those averages, sums, minimum, maximum, whatever the aggregate function is, you can narrow down to a specific set of records. And that's where clause comes into play and becomes very, very powerful. But the basic principle of identifying what you want to calculate as the average remains the same. You really add it as a property, but in this case, in REST console, there is a separate box, but in the actual query that is built, it is going to be specified as a property. All right, so this one is going to be quite interesting because in addition to calculating those values that we have been doing, where it's averages, totals, minimum, maximums, and so on, where we're getting one value, you could actually request the database to group those values by whatever principle that you want to group. And the grouping is a very powerful mechanism that is actually part of the aggregate function functionality supported by Backendless. So in this case, what we want to do is we want to get the total amount of all orders, but grouped by state where the customer is from. So for this, this is the column that we'll be aggregating it by, the total of orders. And then we need to group it by the state that the corresponding customer is from. And then the states here, I think we have orders from all 50 states. So let me demonstrate how this would work. And then this will be a little bit different and you will see why. But first, let me switch to REST console and then I will walk you through of the process of building that query. By the way, let's take a look at what it will look like with codeless and as far as the actual API. So here, what we are doing is we're using the sum aggregate function. So we want to create the total value of all orders. So we'll be adding them up using the sum function, referencing the total column. So this is what we're aggregating by. So all orders and then the total. And then in addition to that, we're requesting an additional property, which will be the state of where the related customer is from. So the customer.state with an alias being state. And then you see that there is this group by connector, which is also a group by argument if you're using our API. And then in here, I'm referencing this alias that I created state. And then what this does is it will do the breakdown of state by state and providing the sum of all the orders for the customers from any given state. So here it looks very straightforward, but let me show you how you would go about building that query with REST console. So here back in REST console, go to order, and then in REST console, we use the sum function to calculate the sum of all the orders. And by the way, if I just run it as this, I will get one value. So this is the total value of all orders without any differentiation by the state. But let's bring the state information in here. And for this, I will do customer.state as state. This is still not sufficient to get what we want, because if I run it, it will still return just one object and we'll just put some random state in here, which is not what we want. What we want is to add this group by. Now, in this version right now with REST console, when I define this variable, define this alias state, it doesn't make it all the way into this dropdown. There is a improvement in our internal system that once you do it, it will add it in here, but it is not available yet. So what we are going to do is we will copy this request URL and then open up a separate browser. Let me right here. So what I have is, this is the request query, right? So as you can see, property sum, and there is also property state. And then what we are going to do is we will add ampersand and we'll just say group by equals state. And now what we got is the result where we got all the information grouped by states. And as you can see, we got only 10 simply because by default, the page size is 10. So if we want to get more, all we need to do is to add the page size parameter. And we can just do 100, even though there are only 50 states, rerun, and now we got all the states with the total number of orders calculated for each state, okay? So by the way, if you don't like this sum property, you can specify here an alias and say as total orders amount, which is going to be the alias that we assign, rerun, and now we have this total orders amount for each and every state that we have in the database. And then this functionality, the grouping functionality, makes it very, very powerful, where you can start differentiating the aggregate calculations for whatever properties that you have in the database. It is super powerful and very useful. This will work regardless of how many records you have. We have customers with millions of records in their database, and they're using aggregate functions all the time, and the speed is just phenomenal. And with this is all I have prepared for you. I hope it is demonstrative enough. There are a lot of different variations that there can be with aggregate functions. So if you're struggling to figure out how to structure your query, please post a question in our support forum. We'll be very happy to assist. And if you have any questions about anything that I described here, please add a comment for this video. But for now, thank you for watching, and as always, happy coding.